second distribution that we discuss over here is binomial distribution. If a Bernoulli trial with probability of success P is repeated independently n number of times, finite number of times, then the probability of getting X successes out of n trials is given by probability of X equal to X NCX Q raised to power n minus X P raised to power X for X equal to 0, 1, 2, 3, so on up to n is called binomial distribution, where P plus Q is equal to 1. The explanation for this is to get X successes out of n independent trials. It means we have n minus X failures. That is, we get one way as A X times, that is, successes are repeated X times, A bar, n minus X times. These are n minus X failures. Being independent, its probability becomes P into P into P X times Q into Q n minus X times, which is equal to P raised to power X into Q raised to power n minus X. But to get X successes out of n trials, we have NCX ways with the same probability. Thus, probability X equal to X is equal to NCX Q raised to power n minus X P raised to power X for X equal to 0, 1, 2, 3, so on up to n. Its tabular form is as under. In the first row we have the random variables X, which take the values 0, that is number of successes, 1, 2, 3, so on up to n. And their corresponding probabilities are probability X equal to X as NC0 Q raised to power n for 0, for X equal to 1 NC1 Q raised to power n minus 1 into P, for X equal to 2 NC2 Q raised to power n minus 2 P square, for 3 NC3 Q raised to power n minus 3 PQ, and for n we have NCN P raised to power n. To find the mean, we know mean is equal to mu, that is equal to summation of X into Px. Putting the values of X as 0, 1, 2, 3, so on, we get 0 into P0, 1 plus 1 into P1, plus 2 into P2, plus so on, plus n into Pn. That is 1 into NC1 Q raised to power n minus 1 P, plus 2 into NC2 Q raised to power n minus 2 p square plus 3 into nc3 q raised to power n minus 3 pq plus so on n into p raised to power n, which can be simplified to 1 into nc1 can be written as n into q raised to power n minus 1 into p. Now 2 into nc2 can be replaced by n into n minus 1 c1 q raised to power n minus 2 p square plus 3 into nc3 can be written as n into n minus 1 c2 q raised to power n minus 3 p cube plus so on n into p raised to power n. Pulling out n p common, we get n p times q raised to power n minus 1 plus n minus 1 c1 q raised to power n minus 2 p plus n minus 1 c2 q raised to power n minus 3 p square plus so on plus p raised to power n minus 1. Well, it becomes again a binomial expansion of which is equal to np times q plus p raised to power n minus 1. But q plus p is equal to 1. Therefore, it is equal to np into 1 raised to power n minus 1. Hence, the mean is np.